Okay.
Everyone give a big wave.
Awesome. Hi, everybody. So good afternoon. My name is Michelle Zhu. I'm the associate chair and professor for the computer science department at Montclair State University. So today I'm very happy to just to give a short talk regarding what I am doing, including the curriculum of the department, my research project, and also some of the current trend in computer science area. So what sub areas that are getting quite popular. So feel free to ask any question. Shia, you can let me know if any of them have questions. Feel free to stop me.
Yes.
Okay, so as a professor in the computer science, so my job is mostly first is teaching. So I teach both undergraduate and graduate level courses. For example, I taught Python programming this summer, and I also taught Java programming, data structure, some of the high performance computing, distributed system. Also, I supervise students to do the co-op at local companies. And also I supervise a master student and a PhD student to do their graduation project. And also I do some, I'm responsible for the curriculum design and the new program design. So for example, in the past few years, our department has proposed several new degree, master degree, several master degree, like master in data science, master in cybersecurity, and some of certificate, like a game development certificate. So I'm also in charge of those curriculum design. And also do some revision for some of the existing courses based on the student feedback and the industry feedback. Another thing I do is I also do some curriculum and student evaluation and do the assessment for the state and also for some our accredited program. Okay. So I just want to talk a few things about the computer and mathematical related jobs in the state of New Jersey. You probably have heard of some of the STEM job distribution and what is computer related jobs in the STEM. But I also look at the local job market. So recently I look at the NJ statistics report. So it look at the change from 2018 to 2028, what type of the computer science jobs and the current number of the jobs versus in 2028. So from this chart, you can see that for software development application, so the jobs would increase by 8,000, about 9,000 jobs. So currently we have 48,000 in not currently 2018, and in the 2028 that would go up to 57,000 jobs. So that percentage change would be 18.7%. And the second one you see is a computer user support specialist and information security analyst, computer occupation, some everything else that in a computer related, and some of the software developer and also statisticians, computer system analysts, and so on. So for application software development jobs, these jobs has a mean advertised salary of over 100,000 per year. And 85% of the jobs require a Bachelor of Art or Bachelor of Science or higher degree. And because our department is currently looking at establishing a new PhD program in the computer science. And so I also look at the national trend of the PhD in the computer science. So especially if you are looking at some research project, the topics, usually they are carried out by the people who has a PhD degree in computer science. And we look at in the US, so from 1984 to 2020, so we see the number of the PhD students that have passed a certain qualification test. And also we look at the number of the PhD production per department, usually for the department that offer the CS in PhD degree. And also we look at the number of new PhD students per department. We can see there's a clear increase in terms of all those three numbers. So that means it reflects the market need for the PhD students that who would be able to conduct the research and also will be able to teach in a college for the student. So if you see the green line, so from 1984 to 1985, it's only about a little more than 10 students per department. But if you look at the 2020, so the number would increase around above 20, so that's almost double the total number of students in the department for the computer science PhD degree. And you may also ask, because for computer science, there are a lot of sub areas, right? So computer science is a big umbrella, and there are multiple smaller sub areas that each of you can focus on, right? So if I ask, what do you do for the computer science? So what area do you know? Anybody know some of the areas? Or you are interested in? Yes? Yeah, I saw a raised hand.
One hand on our side. Finn, do you want to share an area of computer science that you know?
Python?
Yeah,
Coding?
Finn, Python, coding?
Yeah, Python coding, right? So Python.
Maybe we can say Java and Rosie.
Java.
Wait,
You want to share an area of computer science?
what
do you know?
app development
App development?
App development, yes.
that we're working in?
Just name any area of
Computer science and AI.
AI, and AI is another area.
Yes.
Yeah,
Yes.
yeah, those are all some areas that we have that we're teaching here actually.
Okay, so I guess some of you're taking this CS based camp. You learn first of all, you learn how to program, right, in certain program languages. And in computer science, we, like one student mentioned the AI, right? Artificial intelligence, machine learning. That is the one that mostly now people start to use majority like Python or R program languages to conduct research in that area. So if we look at the research area that has been hired by either academia or in the industry. So you see that the number one sub area is AI or machine learning. So we also see other areas like graphics, visualization. We also see databases, high performance computing, and like GPU or human computer interaction to design the interface that the computer and the human can interact with. And there's also like networks, right? Computer networks and operating system. So operating system is one that you install on your computer, right? You have a Windows operating system. You have a Mac OS operating system, right? Android operating system, iOS operating system. People need to design, right? And improve the operating system. And also we have programming languages and compilers. So all the programming language are designed and implemented by human, right? So if there's a need for new program language, we need people to design a new program language. And the robotics, right? I know you have robotics club, right? And software engineering and theory and algorithm design. So those are all those sub areas under the computer science. So if we look at North America for where the people go, majority of the people, like 60% go to the non-academic like industry. They find a job in a company, right? Like a Google, Facebook, And like 40% of the people join the academic unit, like be a college professor and so on. So this table just give us a trend, like at the high level of the computer science. So what are the areas that people are pursuing in the recent years? Then we comes to the Montclair State University. So in our department, so what are the majors and the minors or certificate that we are offering? That also has been updated, and we added some new majors, we added minors, we added the certificate in the past like 5 or 6 years, because our department are looking at the student interest and also the industry and the job market. So what kind of jobs are in high demand? And we also talk to our industry advisor, and see what skills are highly needed. So our major, we offer the Bachelor BS in computer science. We also offer data science, right? So the data science is like data analytics, how to look at the big data and try to get some knowledge discovery from the data. And also that also include the machine learning, AI, data mining courses, and also the traditional information technology, IT. And for the minor, we has a computer science minor and data science minor. So the minor are usually pursued by the student which are not a computer science major. So some students, like if some is in biology, he may want to pursue a data science minor. So somebody in environmental science major, you want to pursue a computer science minor. And we also have a certificate as a game development. So I guess everybody like playing game, right? And I guess everybody, so it just asked me like 2/3 of the population on Earth playing games. So it's okay, like if you like a playing game, but also don't you want to also learn how to develop a game, how to design a game, right? So so we also offer a certificate. That means you only need to finish like 6 courses, then you would be able to develop and write your own game. And later I'm going to show some of the student sample project from this game development certificate student. So the major in the computer science. So you may ask, what's the difference between those majors? So the computer science is the most classic major. It emphasizes on both software and hardware. So try to build a solution combining the hardware and the software solve problem. And it emphasizes both on theory and practice. That means theory, you need to learn mainly mathematical courses like Calc 1, Calc 2, and also the theory, like the complexity, computer theory, all those courses. And for the data science, so the data science is more like an integration of different domains, like it's involved computer science, as mathematics, especially for the statistical research, and machine learning, data processing, and some of the domain expertise. That means if you want to work on a particular domain, you have to have the knowledge of that. I just attended a master defense for data science student. So that student, his undergrad degree is in music, and his master's degree is in the data science. And his project is how to apply AI technique to classify Spotify music playlist. So that is a good example of combining the domain knowledge into the data science. It also has a strong mathematical foundation. In addition to those calculus courses, also require some statistics, probability, those courses. And for the information technology, it compare with computer science and the data science. It is more like how to use existing technology and adapting existing technology to solve the problem. So this one emphasize more on the practice. And it has a less mathematical requirement. So in terms of the math, it only requires one calculus instead of Calc 2 for the CS and the data science. And so the curriculum, so just want to share some of the curriculum. So for the CS and IT major, their first 2 years are basically very similar, that you need to learn Python programming, Java 1, Java 2, discrete mathematics, and data structure and algorithm, and computer system is more like hardware. And the system programming, you're gonna more work with the Linux operating system instead of like regular Windows system. And for the data science, for the one key difference for data science is data science don't need to take Java courses. For data science, is focused more on the Python programming, because for the most of the data science application libraries, they're mostly written in the Python or R programming languages. And also it requires discrete math and Calc 1 and Calc 2, and also it has R programming languages, and also some other data science and statistics courses. And for the after 2 years, the CS curriculum would have more specific courses, like you learn foundation of the programming languages, you learn the history of the programming language, how to design different type of the programming language. Also computer networks, operating system, databases, computer science theory, the security, software engineering. So you look at the CS curriculum, you see you would be able to touch different sub-area of the computer science. And then later on, you would be able to focus on one sub-area for your career. For example, some people like a database for the SQL, right? So that student can seek for the database related jobs in the future. So it kind of try to expose all those main sub-area to the students. And for the IT curriculum after the second year, so we have human computer interaction. So you learn that basically you can, we do a lot of like app design or the interface design. Internet computing is more like a web development, how to develop a website. And network database also, system administration is also one of the key courses for IT students. So how to be a IT manager for a company, for example, and also computer security. IT project management, how to manage a team later on. And also we require co-op for the IT major. So the co-op is you need to find a company that you will have to work like certain hours in a local company, and basically prepare you for a smooth transition from the school to the industry. And for the data science, you see we have courses that introduction to the data science, data visualization, data mining, machine learning, advanced data science, and other advanced mathematical courses. And student can choose a minor. So you see we have all kind of different minors: biology, chemistry, physics, environmental science, mathematics, linguistics. So the reason that we ask a student to take a minor is you should be able to get a domain knowledge, right? So if you want to work on a particular data, for example, if you want to work on some stock market data set, so it's better you have some economics or the business knowledge, right? In order to better analyze the data. And so we also have a new certificate in a game development. So you may ask, right? So you playing all kinds of different games. I can't think of some of the popular game, right? Some of the so how people design that, right? Instead of be a game player, why don't we want to be a game developer, right? So once you develop your own game, you can publish it and you can even sell your game, right? So this certificate for those students who really want to do the animation design and develop a game under a particular game engine. For example, two of the famous game engine is Unreal and Unity. So all those 6 courses, right? You finish these 6 courses, you would be able to get a certificate in a game design. Okay, so let's just so this is some of the student project from our game development 1 that is using the Unreal game engine in the spring 2022. So this is a
Dr. Zhu, we can't see the game if you're showing any.
Oh, you cannot see?
No,
Oh.
I think you have to switch the screen, your screen sharing.
Oh, okay. You see now?
Yes, perfect.
Okay, so in order to save some time, I will just I will stop here just to give you some idea that so these are all the students like in the 2nd or 3rd year of the student who took basically 2 game courses and created their own game. And they also create some of the background and some of the model animation using like a Blender and Unreal, these 2 main software to do that. So this is just a list of all our current degrees, bachelor degree, master degree, also we have 5 years of BS plus master degree. So in 5 years, you can get BS as well as a master degree. So in order to save time. Okay, and currently our students, we have in this 4th semester, we already surpassed 1,000 students. So we probably would have like 800 undergrad students and 200 graduate students. And we have a student-run clubs, computer science club, robotics club, and also we plan to have a game development club. So those students would have a like weekly meeting, some events. Your question?
Yes, so just for the sake of time, we're gonna try moving on to the Q&A. So thank you so much for the slides.
Okay.
They're really great. Thank you.
Thank you so much, Doctor.
Awesome.
So yeah, we've got some questions in this room. So Rosie, let's start off with you. So just come up here and So say your name and your, just move a bit back so that she can see you. All right, so just say your name and your age and what your question is.
Hi, I'm Rosie and going into 4th grade. What's your favorite thing about teaching?
Okay. So my favorite thing about teaching is I would love to see my student improve. So most of the students, especially in the freshmen, they don't have any background in programming, and so my job is to motivate them. And then once I see that they would be able to write their first programming code, and by going through all those debugging processes, then I feel that it's my accomplishment. So I would like to see students improve.
No, that's really nice, actually. Just say your name and your grade.
Hi, I'm Kyle and I'm 9 and going into 5th grade. How many students have you taught?
How many
How many
students?
students have you taught?
Okay, that's a good question. So can you see this slide? Can you see this slide? That's a,
Yeah.
Yeah, so if you see this slide is we had a project. We include some of the local middle school students to engage in some of the activity that integrate the environmental science and computational science. So the student would be able to use some simulation or learn the Python and JavaScript in their activity. So they kind of get exposed to how STEM can benefit from the computation science. And we have, for this project, I think we have over 2,000 students participate in this project. And I have been in a faculty for like 17 years. So I'm sure that my student, I taught thousands or tens of thousands of students so far.
Hi, we have a question here. Hello.
Hello?
I am Grant Hargrove. I am 10 years old. And would you say is your favorite thing about coding?
My favorite thing about coding is I will do something that I like, and also some other people would find it useful. So I would like to share my things with other people. So for example, I developed some simulation program, and then that program has been used by multiple local school districts and in many science classes. So I feel that my work get paid off because people are using that, and then they can learn things from the code that I develop. So I think I want more people to benefit from my code. It can be learning purpose or it can be entertaining purpose.
All right, thank you. Next question is gonna be in this room. Just say your name and your age.
Hi, my name's Nana and I'm 10. What made you want to start what you're doing now?
Okay, that's a good question. So to be honest, when I was your age, like 10 years old, right? I have never seen a computer. There was no computer at my age. And even if when I went to college, the access to computer is very limited. And we have to pay like money to go to a centralized computer lab. And you get like 20 minutes, 10 minutes of using the computer, and you have to pay a certain amount of money. And not to mention that we have a home computer, home desktop. At that time, a computer is extremely expensive and normal family cannot afford that. And so I get to start to get more access to the computer when so after especially during my graduate study. So my undergraduate degree is more like a electrical engineering. And then my master's degree is a computer science. So when I get into the computer science, when I get to learn and take more programming courses, I found that that is a major I really like. So I start to switch my major and take a lot of prerequisite and bridging courses. Then I feel like I really love it. But I think nowadays you guys are so lucky that everybody has computer, right? And if you want to learn, there's so many resources that you can find online. And see, this is a base camp, right? You get a free learning opportunities. So there's nothing that will stop you from pursuing the computer-related jobs or the interest. So that's how I get. So I started very late, but once I get a chance to learn computer science, I feel that I really love it.
No, thank you. We got one more over here. Just say your name and your age.
Hello, my name is Tobin and I'm 10. What is your favorite type of coding?
Okay, so the favorite type of coding. So I bet you must mean the different program languages, right?
Yeah, you mean different programming?
Um,
Yes, he does.
Okay. So I have been learning different kind of languages. So I learned Pascal. My first program is Pascal. I guess nobody heard of that, right? And I'll also learn C languages. Have you heard of C?
How many here have heard of C? Raise your hand. Oh, lots actually in our room.
Okay, good. So sound quite a few. Then
Yes.
I learned Java. Then I learned Python. Then I also learned R program languages. And so all those program languages, they are designed and in different time, like C languages in 1970s in Bell Lab, right? Do you know Bell Lab? That is very close to Chatham.
You guys know the Bell Lab? Raise your hand if you know the Bell Labs really quick. Yeah, it's actually not that far from here. Yeah. Yeah, it's 3 minutes, 5 minutes from here. Yeah.
Right. Yeah, that is where the C language has been invented, and the C has been the like a grandfather of all those some of the later languages, the popular languages like Java, Python. Those all those like the C is like the grandfather, and it's invented in the Bell Lab, right? That is 3 or 5 minutes from the Chatham. So all these languages are designed in different time. And like Java is 1990s, right? The C 1970s, and all those languages has their unique features. And the designer initially they have a different purpose, that objectives in mind. So if I say what is my favorite language, I would say that probably Python and C are two of my favorite languages. The reason Python is one of my favorite languages is it is very forgiving, which means it has a less strict syntax. And for the C, the reason I like it is it has a pointer. That means it's so powerful. It has a more direct connection with hardware or operating system, the kernel, that you would be able to do a lot of powerful things. Oh, of course, powerful things also comes with debugging all the errors that is also will be dangerous. So based on what kind of application you want to develop, then you need to choose the most appropriate language. So just to answer the question quickly, I think C and Python are the two of my favorite languages.
Great, thank you so much. We have a question in this room. Josh?
Hi, I'm Josh. I'm 13. I was wondering, how'd you learn to code?
Okay, so learn to code initially, especially if it is a first learning experience, it's gonna be frustrating because even if you're missing a parenthesis, you're missing a semicolon, you're gonna get error. It won't work. If you mistype, just missing a letter of the variable, then it won't compile. So I think you should start from easy, smaller to bigger, incrementally, and try to be persistent. And one thing I bear in my mind, I know I spend hours, overnight to try to work on my project that will be due next day. So one thing that I believe is nothing is impossible, especially in the coding world. There must be a way to solve your problem. And if you put your efforts and your time, you definitely will get a reward. And don't let the code with the arrow to make you lose your patience. So be persistent, put your time, and then you learn the error that you made this time. The next time you will avoid them. So the more coding you do, the faster and more efficient you will be as a programmer. And I think code cannot play tricks. They are just a source code. You are the master, you control it. So if there's error, don't worry, there must be a way. There might be just 2 or 3 mistakes. If you can figure that out, your code would work perfectly. And by the time you see your code working fine, that is time that you will feel so fulfilled, satisfied. That would motivate you to work on more complicated code. So persistent and be patient. Sometimes you can try to get help from other friends who are experienced programmer. But if you want to be a good programmer, you still need to spend time, spend numerous number of the hours on it and work on different type of the projects. You will feel you will become stronger and stronger.
Great, thank you so much. We have one last question.
Yeah. So, hi, I'm Aditya. I'm 13. So, do you know what exactly is big data analysis?
Okay. So the big data analysis is mostly nowadays it is we are on the data-driven era. That means every domain generate massive amount of data, right? Like biology, medical, they all every day they generate data. So if we don't analyze the data, we want to be able to discover some patterns or knowledge in that. And so the data analysis is more like using some algorithms like machine learning, data mining. So those are all the algorithms. So for example, the data mining, one typical algorithm is a classification. So classification is giving the data. We would be able to classify them into different groups, right? For example, we have, like bank loan applicants. So if the bank want to classify them into different type of group, like low risk, high risk, then based on the applicant information, we're gonna do this classification algorithm. So then we will be able to approve those low risk applicant, right? And then maybe deny those high risk applicant. So this is one of the example that we do the data analytics. And also some people like sales, right? Sales. So we have a sales data from the past 1 year. Each product, each month, what is the sales? So we want to do some analysis on the data and decide what is our best advertising strategy? What is a product that's most popular in the market? So those data analytics will require us to use the programming languages, for example, Python, some of the packages, apply statistics, apply some algorithm to find out the knowledge that we are interested in. So we can better do our business. We can better design our drugs. We can better do some of the disease control, right? And so on. I don't know if that answers your question.
Yes, thank you so much.
Thank
I
you.
think we're gonna be wrapping up here shortly. So it was really great hearing you speak, and I think Adi has a few words he wants to say for our closing.
Mhm.
No, Ishii, you pretty much covered it, but thank you so much, Dr. Drew, for speaking to all of these students right here. Everyone, please give Dr. Drew like a nice wave and say bye. Thank you.
Bye. Bye.
Thank you.
Bye. Nice meeting.